All right, welcome again. Talk about exponents. This time we're talking about the quotient rule. I'll get into that in a moment. Our goal, to be able to use the properties of exponents to rewrite exponential expressions into other equal forms, into other equal expressions, which is where we have solving and simplifying. To use properties of exponents to simplify exponential expressions involving division. So we've talked about some other things before. Now we're talking about division. All right, let's go. All right. Well, let's get started. What is a quotient? Well, quotient is a result you get when you divide one number by another. Is a result? Let's write a little better. Is a result of dividing one, we'll say number, but it could be a quantity, by another. So 4 could be a quotient. Quotient of 16 divided by 4. Could also be a divided by 2, right? So that's our simple, or let's see, 15 or 60 divided by 15. It's 4. It's our long division, even though that's not a long division problem. So we've seen this before, and this shouldn't be anything new or scary to us. Fractions are fine. We'll be okay. Fractions are our friends. Okay, so we're just jumping right into our first sample problem. I have 6 to the 4th divided by 6 squared, or to the second power. So we're going to first write in our expanded form. It's going to give us 6 times 6 times 6 times 6, divided by 6 times 6. Well, what we can really do is this is 6 over 6 times 6 over 6 times 6 over 1 times 6 over 1. Okay, well, what's 6 divided by 6? That's just 1. What's 6 divided by 6? That's just 1. And then what's 6 times 6? That's 6 squared. That's 36. Oof, my one's got ahead of my tens. So what's actually happening here is we are canceling out the common factor. And because the bases, we'll switch to eraser there. Because our bases are the same, 6 is our common factor. But I only have 2 6s down here, 1, 2. And in the top, I have 1, 2, 3, 4. So I'm going to have some leftovers, right? 3 and 4 get left over, and I have 6 times 6. Okay? So what's the shortcut then? Well, if you noticed before, we'll just write this out and we'll discuss it. I have x to the 7th power. If I write it out, it's x times x times x times y squared. That's y times y. And then on the bottom, I have x cubed times y. All right. So I'm going to find common factors that are in the numerator and the denominator. So x, there's 1 of them, there's 2 of them, there's 3 of them gone. Those are my common factors. In the numerator, I have 2 y's, y times y. And then the denominator, I just have y times itself once. So that's a common factor. So how many x's are left over? I have x to the 4th. And how many y's are left over? Y to the 1st power. We don't really write it, but we'll write it for now. So how did I get from x to the 7th over x cubed, and I get x to the 4th? What math operation do I need to put between 7 and 3 that gives me 4? Just looking at the exponents here. Well, if you're screaming at your screen saying subtraction, you're right. When the bases are the same, and we're dividing them, right? I'm dividing x to the 7th power by x to the 3rd power. I essentially just subtract my exponents. I get 7 minus 3, that's 4. And then I have y squared and y to the 1st power. That just becomes 2y to the 2 minus 1, okay? This is x to the 7 minus 3, and this is y to the 2 minus 1. That's how we get 4 and 1. More complicated, and we got some negatives in there. Yikes. Okay, so we can do this one of 2 ways. I will do it the other way. What I'm going to do is I'm going to use the subtraction, okay? So I'm going to have 1/4, right? Because there's a 1 here. This is my coefficient, times x to the 3rd minus, excuse me, where's my eraser? Thank you. Pardon me. Minus -2 times y to the -4 minus 3, because there's 3 down there. The rule is the same. I'm subtracting whatever exponent is in the denominator here, okay? All right, let's use a different color so we can see. So for y, this is the, oops, no, it's not. This is the exponent that's in the denominator, so I'm subtracting it. So when I rewrite my equation, I get 1/4 times 3 minus a negative 2 is a positive 5. And I have y, negative 4 minus 3 is negative 7. Okay, we're not quite done yet. This still looks kind of bad. Not bad, it's not ideal. I got a negative exponent, I got a fraction here that just looks like it's floating out by itself. So I have 1 x to the 5th. This negative exponent means it's going to be in the denominator now, and now the negative is gone. It did its job. It needed to move the y to the 7th to the denominator, and my 4 is in the denominator. So my final answer is x to the 5th over 4 times y to the 7th. A little complicated, but when you stick to the basics, you'll be fine. If it is too complicated, like I said, when in doubt, write it out. So I have negative 4 times x times x times x times y to the 0. Well, I don't know what that even means. Let's hold off on that. 8 times, I mean, I do know what it means, but we haven't talked about it yet. What I mean is, why did I put that there? So if I have y to the 0 minus 2, what's 0 minus 2? It's going to give me y to the negative 2, which is, here's my thing, so which is like, this isn't even here. It's kind of like a 1, and I'll explain how that works in just a moment. So if I'm going to find common factors, I cancel these out. This is what we're doing when we're using the rule. I am saying x to the 3 minus 5. Well, see, here's my 2x times x left over in the denominator. And if I have x to the negative 2, well, that's where they are, right there. So I also have another common factor here of 4. So I have a 4 down here, and I'm stuck with my negative 1. So I have negative 1 in the numerator, and I have 4x squared y squared. This is the final answer. This looked a little messy, and I apologize. I'm a little all over the place. I'll try to clean it up in the next slide. The quotient rule. So to use the general form like we've been using at the end of most of these slides, where I'm going to say b represents the number of my base and n is the exponent. If I take b to the n and divide it by b to the m, remember the important part is here, these bases are the same. That's the same as taking my base and raising it to the n minus m, meaning whatever the numerator exponent is, I subtract from that amount the exponent that's in the denominator. So what happened earlier, like I wrote x to the 0 here, but earlier we had y to the 0. And I said, that's the same as 1. Well, how? How so? Well, let's say y is any number not equal to 0. And we can't have it equal to 0 because it's going to be in our denominator as well. So I'm going to have y to the 5th divided by y to the 5th. Let's write this out in expanded form. That's y times y times y times y times y over y times y times y times y times y. I'm getting a little aggressive, running out of room. So if you see here, we're looking at our common factors. Y divided by y is 1. Right? I'm looking for a pair. There's 1 in the numerator, 1 in the denominator. They cancel. Those are the pairs. They cancel. This turns into 1 times 1 times 1 times 1 times 1 5 times. What's 1 times 1 5 times? That's 1. But remember our quotient rule that we use to explain this. If I'm going to use my general form, this just means I have y to the 5th minus 5, right? My exponent that's in the numerator, and I subtract the exponent that's in the denominator. What's 5 minus 5? Well, that's 0. That means y, any number that's not 0, to the 0 equals 1. I hope that made sense. If not, you know how to get a hold of me. If you're one of my students, your assignment is, guess what? Quotient rule worksheet. We're going to be leaning on worksheets until we jump into the textbook, so just bear with me. Like I said, if you have any questions, get a hold of me. I hope this was helpful. Take care.